shape functions as always. So we use the interpolation 1x y xy. A is equal to x. So we're going to use the an origin centered at the local node 1, so in the lower left hand corner. This is no different than what we did in class last time. So we're going to have x 0 y 0. So the second one is going to be xa y0 a. And I'll go ahead and, even though a and b in the end are going to be equal to one another, I'll go ahead and put them in separately right now, just so you can see. You can verify that the stiffness matrix will be the same as what we derived last time. So there's the shape functions. There's 4 of them. Then the stiffness matrix, if you remember, is we have to derive this B matrix, which is the derivative of the shape functions with respect to x with respect to y and the shape functions themselves in the last column. So we get that. And we have that constant array. I will go ahead and put in, so in this particular equation, A1 equals A2 equals K, right? If you remember from last time. So I will go ahead and put in K 0 0 0 K 0 0 0 0. So then the element shape function is the integral from 0 to A, integral 0 to B, B transpose C B. Took a while, but there it is. So you can verify that that's what we came up with last time. I contend that that was quicker than typing all that out. I don't know if you believe me or not. Alright, so now we need a connectivity array. So the connectivity array is just going to be, I'm just going to count, I'm going to start at that lower left element 1, and I'm just going to, all of the local node numbers are always going to be the same, 1, 2, 3, 4. So I'm just going to count in a counterclockwise fashion and write down the global node numbers. So 1, 2, 6, 5. You okay with that? 1, 2, 6, 5. Then go to the second one, 2, 3, 7, 6. Go to the third one, 3, 4, 8, 7. Back to the fourth one, 5, 6, 7. I'm sorry, 5, 6, 10, 9. 6, 7, 11, 10. 7, 8, 12, 11. And again, this is something that typically your mesh generation tool would provide for you, so you wouldn't have to type them in like this for large meshes. Okay, so now we're ready to assemble. We can say we have to allocate the space. Okay, so we can say constant array 0. There's 12 nodes, so we get this thing, and we're going to assemble by saying k connect I plus equals ke. Now there's no kei because they're all the same, right? It's the same element stiffness matrix. So I'm just going to call that over and over. I goes from 1 to 12. 1 to 6. Yeah, the proper way to do this is say length of connect. Then you don't make that mistake. Who wants to do that by hand? That's only 6 elements. So I hope you guys are starting to appreciate the computer. All right. I think we'll stop here. We got 2 minutes left, and because it'll take a while to apply the boundary conditions, all that. But we'll finish this problem in class on Friday.